Okay, so this is a continuation from the last video. In the last video we looked at how to differentiate ln(y) over x plus 1 with respect to x, and we found our solution to be 1 over y times x plus 1 times dy by dx minus ln(y) over x plus 1 all squared, which actually I've rewritten here slightly. Doesn't really matter, but we can take out this factor of 1 over x plus 1 and then multiply that by 1 over y times dy by dx minus ln(y) over x plus 1. It's just another equivalent form, but it might make things a little bit easier to deal with later. So I've added on this part b, which says that a curve is given by the equation x squared minus xy squared equals ln(y) over x plus 1. We want to find the gradient at the point 1, 1. Well, if we see the word gradient, we should be thinking, oh, we need to differentiate, we need to find dy by dx, which is indeed what we need to do. And because we are looking at a specific point, 1, 1, we're going to find a value rather than just an expression for our gradient. So we need to go through each part, and we're going to need to differentiate it with respect to x. So our first part, our x squared, nice and simple, differentiating that with respect to x gets us 2x. Moving along to the next part, let's keep the minus on the outside here just to simplify this a little bit. We have an x times a y squared. It's a times, so it's a product. We need to use the product rule to differentiate this. Well, we can differentiate x with respect to x, which is just 1 times y squared. It's a product, so we can put a plus there. And then we can leave the x there, and we can differentiate with the y squared with respect to x, which is going to get us 2y times dy by dx. Lots of brackets. Is equal to. And then, fortunately, in our last part, we looked at how to differentiate ln(y) over x plus 1. We used the quotient rule, so let's use our final form there. So 1 over x plus 1 times 1 over y times dy by dx minus ln(y) over x plus 1. So that's our final expression then. Now we could rearrange this to make dy by dx a subject, but that seems quite messy. And for this problem we don't need to, because we've already got our values which we can substitute straight in. So let's substitute in x equals 1 and y equals 1. 2 times 1 is 2 minus, in our brackets, 1 plus 1 times 2 times 1, which is 2 times dy by dx there, is equal to 1 over 1 plus 1, so we have a half, times 1 over 1, which is 1, dy by dx, minus ln(1), which if you remember is 0 over 2. So we have 2 minus 1 minus 2 dy by dx is equal to a half dy by dx. So let's separate our dy by dx's onto one side. Minus 2 becomes plus 2, so you got 5 over 2 dy by dx, and 2 minus 1 is 1. So finally, we can say that dy by dx is equal to 2 over 5. And that is our final answer for our value of the gradient at the point 1, 1 for the curve given by the equation x squared minus xy squared equals ln(y) over x plus 1.